x minus 5 cubed. How about 6 units up? X cubed plus 6. 7 units down. X cubed minus 7, right? Vertical stretch by a factor of 8. So verticals go in the front of your function. So you should have 8 x cubed. Vertical shrink by a factor of 1/7. So verticals, again, move in front of your whole function. Horizontal stretch by a factor of 6. So horizontal stretches and shrinks tend to be the hardest because there's little extra pieces. It's horizontal, it goes inside parentheses with your x, and your factor is the reciprocal. So your b and your factor are actually reciprocals of each other. So this is actually 1/6 x cubed. And a horizontal shrink by a factor of 1/5, so I'm going to reciprocate that. So 5x cubed. All right, I'll show you the answers for number 2, just in case you want that extra practice. You are starting with x to the 5th, so do those on your own and then look back to see what I did. All right, so there are your solutions for number 2, in case you want to look at them and get a little extra practice. Okay, so let's start adding in some new information with the information we already know. So, example 2, we're going to describe the transformation. Describe is something that you do in words, and they're going to sketch or draw out what that g of x might look like. So, f of x is my first function. So, on my graph I have x cubed graphed for me, and I want to describe and sketch the g of x. So, I look and I see 2 different things happening here. I see an addition of 5 and an addition of 2. That 5 is in my h position. Since it's with my x, it's not what I think, so I actually have an h value of -5. That 2 is in the k position. It is outside parentheses, so it broke up with the x and is true to itself. So this function, g of x, needs to move 5 units left and 2 units up. So in order to do that, I need to find some points. So I see 3 really pretty points here. And I want to move those points, all of those points, in those same ways. 5 left, 2 up. So 0, 0. I'm going to go 1, 2, 3, 4, 5. I know I go off the graph. 1, 2. So it's in here. I'm going to take that 1, 1, 1, 2, 3, 4, 5, 1, 2. And it goes here. And if I take my -1, -1, I would literally be off the paper, so I can't really do that. All right, and this is what a g of x would look like over here. All right, so number 2. We are starting with our first function of x to the 4th, and how many things changed in g of x? 2 things. We have that negative in front of our function, and we have a positive 2 inside with the x. All right, so let's do the easy one. Inside, that's the x minus h. If x minus h is positive 2, what is your h value? -2. If you have a negative in front of your entire function, your x's become negative, so you reflect over, your y's become negative, so you reflect over the x-axis. Okay, so this is reflect over x-axis, right? So your y's are negative, so you're moving down to the bottom of your graph. And h being -2 means you go 2 units left. Okay, so this one's an interesting process to think about the order to do that in, but we're still going to do it. So find 3 points. There's 3 pretty points right there. 0, 0, 1, 1, -1, 1. You want to reflect each point and move them left. So if we start with our 0, 0 and reflect it, it stays in the same spot. So all we have to do is move it left. 1, 2. There's that new point. How about 1, 1? When it reflects over, where does it go? Okay, we're using that mirror, so it moves down here to 1, -1, and then 2 units left. Okay, 1, 2. Right? If you take your -1, 1, it reflects down here and then moves 1, 2 to the left. So we now have approximately this here. Oops, I didn't go through that very well. That's okay. You know what I mean. There you go. Is that better? Okay. So, try number 3. Pause it if you want to, or just do it while I do it, and then look to see if our answers match. All right, so be careful. That +1 at the end is actually the same, so it does not change at all. So don't think that that is a k value. Do not move it up 1 because it was already there. But you should see negatives inside with your x's. It does not mean a double reflection. If all of the x's become negative, you're reflecting over the y-axis. All right, try your graph. This is interesting. You're going to have to use your brain to try to reflect something wiggly in a mirror. All right, so yours should look hopefully similar to mine. So every single point flips to the other side of the graph. So think of that y-axis as a mirror and everything flips over. Right, it's kind of a weird concept to do.